Okay. So I have some good news. I have some bad news. No, that's not what I want. Okay. Here we go. The good news is there was a person that got a problem 100% correct. The bad news is no one else got a problem 100% correct. It was Tolman Walker. Obviously. Okay. So I have 19 kids on the whatchamacallit class. Ed Puzzle, thank you. I had a stroke this weekend. It's like my 10th one this year. Anyway, 4 people still haven't done anything. It is helpful. Welcome back. Yeah. Okay. So this is a slide from last year. They redid my computer, and I thought I backed everything up, but I didn't back up anything that I've done this year in AP, which makes me super excited to be alive, because who wants to do work twice? This guy. It's just not my year with technology. But please, the next few days, they are tricky. Okay, so please, if you haven't watched the video, let's watch them. They do help, even if we're going to go over stuff. Someone say something? Yes. Mostly this morning. Some during me time, some. Mostly I did it between 6:45 and 7 this morning. And the second question is undoable. I'm an idiot. I don't know where the other word went, but you need to know what Mercury's with, so you know Mercury's charged, so you know how to balance the other side.
Yes, I just guessed.
Well, it's okay. Just guessing's great. Everyone got it right. All right, plan to today, molarity. We've already done molarity because the way that the book, the new book is, but just to review, molarity. It is a capital M, which means it's moles per liter. Most problems will give you milliliters. So be careful. To go from milliliters to liters, you move it 3 places. That is 0.085 liters. I'm going to assume that you're pretty good at that. Are we need molarity too much because we've already talked about that. Oh, so here we're just going to dive into it. And if you're like, man, I already watched these videos, I feel like I know everything. One person knows everything, and he was shocked that he did, right? So no one knows what they're doing. So let's make sure. No, absolutely not. They're not for nothing.
Taking a picture of this.
How many times you're like, if you're going to learn to play piano, do you only go to practice once, Bennett? No. You learning now will be easier because of the Ed puzzle. All right. So solution stoichiometry. We've been doing stoichiometry already, but now it's in a solution, and we're just going to add just another layer to the very fun onion. All right, so we will essentially follow these steps, which were on the Ed puzzle. Maybe not written the exact same because these are written 6 years newer than the Ed puzzle was, but they're basically the same idea. So first, we need to balance a reaction. There's nothing new there. We need to determine solubility, or sorry, precipitate using solubility rules. All right, we need to find the limiting reactant by looking at moles given or by using both given moles to solve for grams of the precipitate. So there's, or it doesn't mean we need to do both, whichever way you feel comfortable with. Right, then we find the grams of the precipitate. To do this, we take the moles and convert them to grams. The moles are dependent on the limiting reactant. That's something we've already been. Where did that come from? Yeah, my voice just literally stopped for a second. No, it's inhaling my mask. All right. I don't know. There was a special, they were pretty cheap on these asbestos face masks. It was a joke, but no one gets it because you don't watch late night TV and get mesothelioma commercials, whatever. Moving on. Okay. Then everything that I have a check mark so far is easy, or I should say, should be easy. Then it gets a little bit tricky. All right, the concentration of the ion, find concentration of each ion by first, the concentration of the ion in both the limiting reactant and precipitate is, this should be molar. Molarity, not grams. I apologize for that. Okay, because it says concentration. That's what brackets mean. We've said that in this class, right? I hope. No? Okay, well, it's on the video. Brackets are shorthand for, I don't even want to write it. It's just too long of a word. There's a T in there somewhere. All right. Brackets are shorthand for concentration. So the concentration of spectator ions is equal to the initial moles over the new total volume. All right. This one's usually easy. This one's brain thinking. And this is the one that usually is hard for kids. All right. Is the audio still good? Medium? This is great. They redid my computer, but when they did that, it no longer works for audio. So I'm doing Zoom from my computer, but doing audio through my laptop, and it's kind of bizarre, but whatever. I think that's actually wrong. More devices, more problems. Okay. The concentration of the ion in the precipitate and excess reactant is equal to initial moles minus used moles over total volume. Okay. Sound familiar? It should be pretty similar. Okay, let me just cut and paste this. From the Ed puzzle, we had a practice problem that it could have gone better. We'll just put it that way. It went a lot like my weekend did. I thought it was fine, and then it just wasn't. I don't know. I'm too negative. I didn't mean to be negative.
Yeah, are we still doing the tapes?
The what? No, ticks. That was Friday only, kids, so zip it. How do I even know? How do I find the problem? I'm so confused. Okay, hold on, Thomas. There we go. And how was I mad? I don't remember being that ornery. Like my marriage. You never know when what you say is misconstrued. I have no comment because this is being recorded. So no, let me be 100% truthful here. I married an incredibly amazing human being. So no, there's no buts about it. She is so patient and happens to be gorgeous at the same time. So it's perfect. Okay, here we go. Let me sit so we can, oh, and I already did this on paper. All right, you did this already. Who said that? Right, everyone did it. It's from the video. But just a
Yeah,
reminder.
who did it right? One person in this entire class.
Yeah, there are some people that were close.
Was I close?
Soraya was super close. You were half close.
What? Was that bad?
And then
I was.
everyone else, you just sucked. So
I have pain ahead.
let's be real. And I don't mean to hurt your feelings. Hopefully you don't have any. Okay. MgCl2 plus AgNO3 goes to MgNO3 2 plus AgCl. You know what's depressing is when someone puts AgCl2 and then they're wrong on everything because they didn't know the charges. That's depression, kids. All right, then I should balance it. It turns out in this problem, if you don't balance it, it done ain't matter because they end up being 2, 2, and 2, which is really 1, 1, and 1. Okay, but you should. 1, 2, 1, 2. There you go. Now, my friends, this could save you some time. We're talking about a precipitate reaction. The next thing is to know the solubility rules. Which one forms a solid? All right, this is my solid. So really, I'm mostly going to just worry about 2Cl minus plus 2Ag plus goes to 2AgCl. Now, there's a bunch of 2's there. Whatever. We could, if like I said, if you messed up, it wouldn't have mattered. All right. Onliners, I can't see now. Are you able to chat? If you need help, chat or text me, because whatever, hit me up. Oh, I forgot to turn that off, huh? They won't. They wouldn't do that.
Please, someone
I
do it.
thought about
Please,
it
someone do
when I was Zoom calling, but I was like, no, I don't want David to see me.
I would have been good. Hold on, I'm doing the Zoom real quick.
Don't do it. Thank you for reminding me, Logan. Okay.
You just disabled it.
Ah, all that work to get onto the Zoom.
What a letdown. Okay, here we go. We don't really, that's posted to YouTube also. That's embarrassing. Okay. Now, my friends, let's do this. So I know this is my precipitate. This is my net ionic, which just using this equation will save me some time eventually. Find the limiting reactant by looking at moles given or by using both given moles to solve for grams of the precipitate. Okay, please stick with me here. We got to be careful. This was from the video. My magnesium chloride is defined right here. I have 0.3 liters of magnesium chloride. Is everyone okay with that being 0.3? I have 2 moles of it. To find the moles, molar. To find the moles present, I multiply 0.3 by 2, and that is 0.6 moles. And this is where you went wrong recently, because you were perfect except for this one step. 0.6 moles of MgCl2. All right, silver nitrate. You'll see what I mean in a minute. I do the same thing. I take 0.5 liters and multiply it by 3, and I get 1.5 moles AgNO3. Okay, stick with me for a second. I suck when I try and do shortcuts with my own math. So I'm pretty detailed here. So just follow what I'm going to do here. I just found out that I have 0.6 moles of this. Are you okay with that? All I did was write it underneath. And I have 1.5 moles of this. Now, please, please, please be careful. If I have 0.6 moles of MgCl2, how many Mg moles do I have? Not one. Well, 1 times 0.6, right? That's for Mg. But how many Cl do I have? I have 1.2. Reese, your math, you used 0.6 right here. At least that's where I think you messed up. How about that? Right. Okay, now Ag, there's just a 1 and a 1, right? That's 1.5 of Ag, 1.5 of NO3. You don't have to do these steps, but remember a long time ago I said the best kids in this class are the best accountants. You remember me just saying that one day? It's those details to numbers that those kids are the ones that really get it. Okay, now follow this idea. This is what's reacting, right? So really, I only have to care about Cl and Ag when I go to determine my limiting reactant. Now, one more thing. Would everyone be okay if I canceled my 2's out? Okay, so now what I'm going to do, I hope it doesn't confuse anyone. How many moles of Cl minus do I have? 1.2. It's okay. Ag, what, Grace? 1.5. Okay, now, since these have the same coefficient, the limiting reactant is just the smaller number. Okay, if they have the same coefficient, the limiting reactant is the one with a smaller number. Now, here's something that's also cool. If they're the same coefficient, my excess is just equal to the difference of the two numbers. And I would have 0.3 moles excess of what? Ag plus, right? Now, I know that was, you're like, what, is he just doing magic? Yeah, I am right now. But we'll do these over and over, and it'll hopefully click. You guys are gifted with incredible brains, so just be patient, it'll come. Okay, so what is my limiting reactant in this reaction? Just the chemical. It is this chloride ion. Now, on the test, if you put MgCl2, you'd be right. That's fine. Okay. Now, what I would do, I would now use my math. I would say, all right, I have 1.2 moles. Hopefully on a test, you really wouldn't do this way, of Cl minus. Looking up here, I can still do the 2 or the 1 that I reduced it to. It doesn't matter. I'm going to say for every 1 mole Cl minus, how many moles of AgCl did I make? 1 mole AgCl. So how many moles are there of my precipitate? 1.2. And so to find the mass of my precipitate, I take my moles, 1.2 moles, and I multiply it by the molar mass of AgCl. And I get 170.4. I should have my phone over if I told them to text me in case of emergencies. Okay. So the grams of precipitate was 170 point what? 4. If you do it using the periodic table, like for AP, you get 171 point something. And Soraya and Tolman had that number. And then, let's see, I really think it was just Reese. She had half this number because she forgot to double there, is my assumption. That's where you got half. Okay. Now, I'm done with parts, but not all of the problem. And this is sort of a mess, but I've been able to find this, right? Then in step number 5, I already know this one. And remember, this is supposed to say molar. I'm sorry. Find the concentration of the ion in both the limiting reactant and the precipitate. Tell your partner which one is in both the limiting reactant and the precipitate. All right, so that's Cl minus, correct? All right, so I'm going to say the concentration of Cl minus is equal to 0 molar. And on the AP test, if it's 0, you still should include the unit. Yep. You'll get 2 points for this problem. 1 point, 2 point. What's that? Yeah, you can have the wrong number in the right unit and you can get 1 point. No, this problem right here would be worth 9 total points. So you could get
4 out of 9.
You could get 1. All right, here we go.
That's still a 3. I'll take it.
That's a high end.
Let's focus. Ag plus, NO3 minus, and Mg plus 2. These are my other ions, right? Okay, let's come back up to the rules. Okay, don't then. Let's come back up to the rules. So we found this one. Spectator ion concentration is equal to initial moles over new total volume. And sadly, right here is like one of the easier parts, but one of the most screwed up parts that we have. So here we go. The spectator ions were what 2 ions? All right, so NO3 and Mg. You don't have to write everything this way. I'm just doing it to be super clear. This was my limiting reactant. I'm going to say this is my excess reactant. Okay, so right now we're going to be finding these 2. So I take their initial moles, and that's why this top part was, in the long run, pretty helpful to me. It helped me determine the limiting reactant and the excess, but now I'm ready for the lower ones. So my initial concentration of Mg was 0.6, right? And from the top, my NO3 was 1.5. Fair enough. And these were moles, not concentration, I'm sorry. Moles. To find their concentration, I now divide them by the new total volume. Like I said, this is almost always, if you're smart but screw up, this is the step you'll do it. You need to add the 2 volumes, which are 300 milliliters and 500 milliliters. And you need to get the denominator for both of these is 0.8. And I'm pretty sure there's 2 or 3 people that they had that problem. Okay, then I can do this math in my head. This one I don't remember. 1.875. Okay, never mind, I do remember it. And 0. So we have 3/4 of them. The final one is my excess reactant. And once again, I already have the number I need. It was right here. Remember that step? We said my limiting was 1.2. My other one I had was 1.5, so the difference was 3. There was, or sorry, 0.3. So there's 0.3 moles of Ag plus left over. And my new volume is always the total of both. And I don't remember this one, 0.3375. And here are my answers. And then I had 170.4 grams or something like that is my precipitate. Doesn't sound that bad, does it? Okay, Grace and Judah, I felt that. All the concentrations.
Was this in the last video?
Oh, got you. What's
Was this
that?
from the last video?
This is from video 3, the first of the 2.
I got the Spectator Ions, right?
Right, the only thing you had wrong was this mass.
Oh, just the mass?
Uh-huh. All right. Let me, this will be tricky. I don't even know if this will be helpful content. Let's see here. Okay, so who, raise your hands and I can see you two online now. If you can balance a reaction, raise your hand. Okay.
I can manage that. I can do that. I did that.
So would I have
Okay.
passed on the AP test on that question?
Yeah, you would have passed it. Okay, raise your hands. Raise your hands if you can determine the precipitate now. Okay. Raise your hands if you can determine a limiting reactant. Okay, so there's the first hurdle of the race, the limiting reactant. That's pretty common. All right. So some of you checked out here, you can raise your hands still if you know how to do the other parts, just not that. So if you can find the grams of the precipitate, raise your hands. Okay, so there's hurdle 2. That one's a little slower than the other one. All right, who was okay? It doesn't mean that you can do it perfect right now. Finding the concentration of the precipitate and the limiting reactant. Okay, that's the biggest hurdle so far. Who was okay for spectator ion concentration? Okay. And then this last step, who got lost here? Sorry, who can do that part right there? 1, 2, 3, 4, 5, 6. Okay.
It's just division.
It's just division. Well, the problem is math isn't hard, but doing the chemistry to get to the math is hard.
Well, that wasn't the question. It's just asking if you can divide. That part is just dividing. So can you do it divide? I mean, yeah, but I can't do the rest.
Okay, well, now I know that. And I know now I can't go the other direction. Oh, of course. We're going to do like 5 more of these.
I need a calculator.
All right.
Reese, you want to grab me one, please?
Looking at this one real fast. Okay, this one will be harder. Does anyone know what made the last one not that awful? There was one huge thing that made it easier. The code. All right. Can you hear me now? Is it acceptable? Okay. Let me move this. What am I doing, Tom? All right. Sorry about that. Thank you for hitting the chat. My battery on my wireless mic just died. Whoever said that, yes? Okay, let me do the equation. Now, girls, on my, can you hear me right now if I sit here? Good enough? All right, here we go. Let me write this out. So AL, well, that's is too bad. We're not gonna have room. This is literally the first time I've ever seen Leslie's face. He always has a mask. All right, here's the balanced equation. Well, sorry, here's the equation. I haven't balanced it yet. What's step number 2? Okay, so what's my solid?
Solid is the aluminum hydroxide.
How do we know that?
Because nitrate never forms.
Okay, because it will never, ever, 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 ever be something nitrate. Yeah, John.
How did we determine aluminum nitrate?
Because of the.
Because it was mixing
metals.
with nitrate.
There's 2 ways. It is always a +3, or there's 3 nitrates, and nitrates always a -1, so this had to be a +3. But you should memorize aluminum is +3. It is always +3. Okay, so my precipitate was aluminum hydroxide. So I have why did I put that first? Oh no. What? That was miraculous. I don't even know what happened right there. Just, I don't know why I put it in parentheses, but when I went to erase it, it turned into a curve. So just go with it. Are we okay with that?
Yeah.
Thank you for your patience. All right, next step, determine limiting reactant. What I'm going to do that, I'm just going to write how, because that is something I can use later. Okay, so 0.3 times 0.6 equals, is it 0.18?
Oh, yeah.
0.1 times 0.8.
No, it'd be point.
Oh, you times it, you divide that.
You times it.
Zero.
So 0.1 times 0.4,
I'm stupid.
0.04, are we okay with that?
Yeah.
Who's lost? Did I already lose anybody?
So this is like the shortcut of the picket fence.
I might use the picket fence still. I'm just finding the moles, which I may or may not use in a picket fence eventually anyway. Okay, now I'm going to come down here. Of all of this thing, I have 0.18, right? Which means aluminum, I'm going to put it in blue, Aluminum, there's only one of them, so it's 0.18. Nitrate, though, there's 3 of them, so that's 0.54, is that right? All right, Na and OH, they're both 1-to-1s, so that's not bad. I have 0.04 of Na, 0.04 of OH. Okay, whoever, was that you, Judah?
Yeah, but there's 3 of the whole group.
Right, but I love that you said it, because that will confuse people. This is tricky. We care about the sorry, I screwed that up. We care about the subscript when we do this, but not the coefficient. Okay? The coefficient's taken care of when we balance things, but not when we break them apart. So perfect, even though you realized the answer that was needed to be stated. Okay, so now I'm ready to roll. I'm going to come and write these values down here, if you're okay with that. I have 0.18 and I have 0.04. Now I'm ready to ask myself the question that we had last week that we were okay with. Look at the screen for a minute. I'm going to say, is 0.04 3 times bigger than 0.18? No. So which one is my limiting reactant? All right, I'm going to put it right here. OH minus is my limiting reactant. Now, could you do that through a picket fence? Absolutely. It's fine if you did it, absolutely. I just did it through that idea. Okay, so now, the next step is to find the grams of my precipitate, correct?
Yeah.
Okay, now we gotta be careful here. I need grams of AlOH3. All right, now, this one, it really, I would use the picket fence personally. 0.04 moles of OH minus. I'm gonna need more space. What unit would be down here? Okay, the number is 3, the unit is moles, OH minus. I'm definitely gonna need another picket on this. Okay, now, where did this 3 come from? Tell your partner.
There's 3 of them.
All right, there's 3 of those, but I'm going to AlOH3. So how many of those are there? There's 1 mole AlOH3. What must come down here? So 1 mole AlOH3. And what must be on top? Okay, whatever the molar mass of this is. Does anyone have that number?
I got 80.
It's got to be way more than that.
Plus-
No, you're right. It's 87, 80 what?
Oh, I did it wrong.
70 what? Okay, yeah, it was around 80.
Yes.
Yeah.
Okay. Now, can we take a time out and let me ask you this? Why, in this problem, was it not just 0.4 times 78?
Because there's
the
3
moles
moles
are
of-
different.
Okay, because the coefficients are not the same like they were in the last one. So it's harder. Okay, what's our answer here?
1.04.
That's the grams of, yeah, aluminum, I'll just put PPT. That's precipitate. So that's the grams of AlOH3. Okay. Next step is to find the concentration of the thing that was in both the limiting reactant, so I'll circle that, and the precipitate. So which one is it? I find OH in both of those circles. So the concentration of OH minus is equal to what if it's in both of those? 0 molarity or molar or moles per liter. The next, what's that?
Did you need to put the brackets?
Yeah, because it wants concentration. Bless you. You know, and Judah, if I don't put them here, this answer with a capital M, you don't have to do both, so it's fine. All right, the spectators were next. What are the two spectator ions? Okay. Na and NO3. And this is where the top, finding these numbers helps me out. What's my concentration of NO3, or my moles? Sorry, what's the moles of Na to start? 0.04. I'm going to divide that. What's my new total volume? 0.4. So that equals 0.1. Is that right? Tell your partner where we got the denominator. 0.4. Where did that come from? PPT is just short for the aluminum hydroxide. So when we did this pick and fence, the answer was grams of AOH. So this is a shorthand for saying the word precipitate. Okay, my 0.4 came from adding 300 and 100 and then converting them to liters. Okay. Now, the last thing to do, I didn't do this one. NO3, I'm sorry, well, it's 0.54 divided by 0.4, that equals 1.35. Okay. That rectangle didn't work out very well. Okay, then this one's harder. What are we left with now? AL. Okay, I need to know how much of it was left. So to do that, I need my initial minus used. And that will tell me how much I have left, correct? Okay, and I'm going to divide this by new volume. So what was my initial AL? 0.18. Okay. Now the use is a little bit tricky. I did not use just 0.04. I used 3 times 0.04.
Yeah.
Bro, I got that part right. Oh my gosh.
Wait.
Standing.
That's
Why
okay.
understand? Why is it green?
Why are you guys looking at me so angry like that?
It's not.
Well,
we're talking about. Guys, we're talking about.
No.
Yeah.
Oh, it's the other thing, the
Whoa,
product.
whoa, hey, let me, it's a 3-to-1 ratio, so maybe I have it wrong. Is it 1/3?
It's not a third of 0.04. My brain is thinking you need 3 of those.
Yeah, I could be wrong. I could be wrong. Hold on.
No, because if you're wrong, Davidson, I'm wrong.
The
I can't
entire
really take that
thing,
today.
a point
I'm
of
trying to
four.
revise.
And so if it's all.
What are we doing? We're doing OH, right? Or no, AL?
Yeah, well, there's
Now I understand
3
what you're
moles,
So what was my precipitate?
AL,
Not my precipitate, my limiting was OH,
Yeah.
right?
I just need to be right today.
Okay, it is 1/3. It is 1/3.
Yeah.
I am sorry.
That's
Just-
right.
Wait, it's one.
Yeah, you'll put the moles down
Does
here.
that always work like that? If there was a four, it'd be 1/4.
Well, whenever you use the word always, the answer is always no. Because it just
Always?
always. So, no, it's fine. We can do it in picket fence.
Wait, actually,
I just had it flipped in my head and I apologize. This was 0.04 OH minus, right? We're looking for moles of AL. So I don't need this part. It worked. No, it didn't. No, it didn't. We're just gonna go here and ignore that. Oh, Nelly.
It's a moles in caps.
Moles of
Open
AL.
important
So if
moles.
you look, and this is my fault. I screwed up a lot lately. People are really good at telling me I have. If you look right here, there's a 1 to 3. I just had it upside down in my head. So 3 moles of OH to every 1 mole of AL. We don't need this, but you've seen how erasing is working. So take that and divide it by 3, and what do you get? 0.04 divided by 3.
Wait, so how did you get the 0.12 used?
Because he did it wrong.
That was wrong.
That's where I had it wrong.
That was wrong.
This is, so why did you use the 0.04 though?
Because this is my limiting reactant. I always start everything with my limiting reactant. And it was moles of OH. This looks like a number, but it's OH, 0.04 of OH. And I want moles of AL used. To solve for moles of AL, it was a 3 on the bottom, a 1 on the top. I take 0.04 and divide it by 3, and I get what answer? Point what?
What? It's 0.16 repeating. What?
Yeah.
I got
0.1013.
I gotta do it online now.
Oh,
I got
It's 4/3. That's
Okay.
1.
Oh, sorry.
How
No,
much-
it's
oh, so now we use
0.013, and then the next
Okay.
thing after that is 0.1.
Imagine if you're at home right now wondering why we're all fighting. Okay. This answer is
Shut up.
0.133, correct?
0.01.
0.01.
Okay, that's used. If you're online, they were giving me the overall answer, not this. That's why there was. Okay, now, what was my initial? I have that written up here. 0.18 minus 0.0133. And what was the new volume? We used it twice.
0.16.
No, the new volume was 0.4.
Oh, wait.
And then what is the overall answer?
It's 0.041.
Do we have agreement with that?
Are you talking about the initial divided by the volume?
No,
Or
he's talking about the total.
that number?
I'm looking for 0.18 minus 0.0133 divided by 0.4.
The whole thing would be 0.42.
Yeah.
That is your.
No, 0.0.
Shoot me.
0.0.
Yeah.
Give me, I need some more agreement.
0.42, just a moment.
Who has
I
0.42?
have
Raise your
0.0.
hand.
I have to divide it.
0.042, raise your hands.
Did you divide by straight up word?
Oh, shoot.
You gotta divide by 0.4.
Yeah.
So 0.42, we're gonna
Yeah.
agree with that. Okay, that went super well. And that was AL plus
The
3.
worst is finding that XX.
Yeah, for sure. Okay, get ready to take a picture.
Picture.
Don't give up. Here we go.
Why do I need to take a picture?
Because you're gonna do this tonight and come back with it tomorrow.
Are you serious?
Oh,
Do I look
that's nice.
serious?
I'm ready to get it now.
How long do we have?
David, what if I could convince you?
You
Are we doing
can.
this all day tomorrow too?
We'll do more practice. We definitely need it.
Well, That's what we're doing.
But yeah, I will record it
I
and post
needed
it.
it.
Good, because I really need help.
I'll actually talk about
Everybody needs help.
Okay, okay.
Brain.
That excess.
There's no brain.
Brain,
Yeah.
Okay,
Okay,
that excess.
not,
Take my brain.
Don't kill me.
not that I'll be super helpful.
That's it.
Yeah, it's huge.
Well, that's probably blocking that. How can I help you in 1.5 minutes? I don't know.
That would be
No,
pretty
don't do
efficient.
that.
Make a wild guess.
This one will be easier than the last one.
On this,
It's ones and twos. Those are a lot
you won't have to
easier.
argue with it.
No, no.
Am I gonna, oh, I get it.
Holy moly.
Oh, it has to be this. Oh, I got this.
Okay, are you girls kind of all right? It's hard. Sorry that you have to be home during this, but try that practice problem. Did you guys get it written down or copied? Okay. Try that. We'll go over that the first thing tomorrow. Sound good? Okay, we'll see you guys tomorrow.